Hello, welcome to today's live stream, which will be about essential tools for JetBrains IDE plugin development. Today, together with Yann, Cébron, and myself, as developer advocates for IntelliJ platform, we're going to discuss the most important tooling when you work on plugin development for JetBrains IDEs. We'll start with Yann's part in the beginning, to which belong two tools, which are Plugin DevKit plugin, supposed to simplify plugin creation, PsiViewer, which helps you navigate through the PSI tree. Then we'll jump into the UI inspector tool, which I'll take care of, and then switch back to Yann, who will talk again about index viewer plugin, which allows to debug index contents while developing language, for example, related to plugins. So yeah, let's begin. Yann.
Hi. Well, I think we should first show the slides about the recording.
Yes, I'm sorry.
So just in case, you can ask questions anytime, and we will collect the questions at the end and handle them after the presentation is done. I hope we have plenty of time to take into account all your questions today. And of course, this webinar is being recorded, so you can go back and look at specific sections later on. And it's also added to the list of our webinars in the SDK doc, so you will be able to find it from there as well. So yeah, today's webinar is some kind long overdue. We've been talking about doing such a webinar for many months or even years. And we have finally come up with this plan for today. So I'm going to start with the Plugin DevKit, which has been there for plugin developers, I think, for must be roughly 20-ish years now. I would have to look back in the Git history, but it's been there for quite a while. But the features have expanded quite a lot in the recent years. So it's probably a good idea anyway, even for people who are familiar with plugin development and who have been using the Plugin DevKit. I hope that you can all learn a bit new bits and pieces today. So basically the idea of this webinar is to go through the tools in live. So we are basically staying in the IDE for most of the time today, and we'll be demonstrating the actual features in the IDE. All right, so let's jump into the Plugin DevKit support. The first area I want to cover today is the support for the plugin XML editing. But before we do anything about plugin development in the IDE, as a plugin developer, there's one thing that you should enable manually once, and that is called the internal mode. You can find the instructions in the plugin SDK docs. It's basically just setting a special property and then restarting your IDE. And after that, we will have plenty of new options in the internal actions menu in the IDE. So it's a good idea to do that before you start writing plugins in the first place. So the Plugin DevKit needs to be installed manually during the last few IDE versions, but that's just a one-time action, and after that it will update itself just like any other plugin. And the first part I want to show here in the plugin XML highlighting is something that is new in 2025.1. So the upcoming major release, and that is we have finally integrated on-the-fly documentation for all the elements in the plugin XML. So you can just hover over the tags here and can see the documentation contents. You can navigate the tags and the attributes here, and it will show you all the nice information right in the IDE. And the interesting part is that this is basically the same information as we have in the SDK docs for a long time. So the contents of the docs are shared between these two and are constantly basically updated. So anytime anything changes here, you will have up-to-date information both in the SDK docs as well as in the IDE. And this is pretty useful if you use some attributes that are maybe a bit more exotic and you are not quite sure what they are about, or if you want to get some additional hints on how to use things properly. Documentation does not stop with the fixed tags that we have in the plugin XML file. If you have already developed plugins for the IntelliJ platform, you will know that the major part of the functionalities is exposed by plugins via extension points. And right here, we can see a number of registered extension points. This is basically, this is also the Plugin DevKit plugin itself in the IntelliJ community sources. And hovering over an extension will also show documentation in the IDE. So we will see the underlying interface or extension point bean that needs to be configured here, show the Java doc basically, or KDoc from this class right in the documentation pop-up. And there's one very interesting thing up here. There's always a link to open the existing usages in the IntelliJ Platform Explorer web application. So you can quickly go and look what other plugins, how they have used this extension point. So for example, if I go right here and I open this in my browser, we can see that we can explore all the existing implementations from open source plugins, which are hosted on the JetBrains marketplace. So this will then quickly allow us to jump to the actual source here. And then we can look at the implementation and maybe learn a bit from other plugins. So that's a very useful shortcut to quickly find sample code. Of course, there's not only documentation, but also code insight on completion for everything. So the regular tags that we have up here are completed as well, of course. But the most interesting thing is here completion for all the extension points. So for example, this extension point again has a language attribute that we can specify. Again, documentation is also available for the attributes of the extension point right here. We can also navigate to the declaration of this element. So we can see the underlying extension point bean here. And we have, of course, also code completion for most of the attributes. So for example, this language attribute is basically some hard-coded smartness in the plugin XML editing. So whenever an extension point has this extension attribute, auto-completion will be available automatically. And here we can see all the registered languages that we have and choose the right identifier for the language, because sometimes they are lowercase and mixed case or uppercase. So that's very convenient to have auto completion here, and you can even jump to the actual language implementation right from the plugin XML. The same is true, of course, for all sorts of other arguments. There is a special thing about the order attribute, which allows you to order extension point implementations. So we can tell the IDE to load them first or last or after or before a specific other extension. using its registration ID. Of course, autocompletion is available here as well. Let's see what else we have. For inspections, for example, there are many more attributes here. And one thing that you will also notice is that there's very smart code insight for everything regarding internationalization. So this here is actually a key to a message resource bundle that determines the group path of the inspection. So basically some display string related to this inspection. Same here. And we can see the actual text and the bundle where the resource key is defined. And of course, as you would expect, search also works the other way around. Yes, so that's, I think, some stuff about the extensions. There's a couple more attributes which are hard-coded and available automatically. For example, action ID is one of those hard-coded attributes. Enums are fully supported as well if your extension point uses them to configure anything, and so on and so on. Let's go further with the internationalization and code insight. One place where this is very obvious is for actions, which are registered here in the action and group tags. And what we can see here is a small gutter icon with the pop-up related property. So this allows us to navigate to a related message resource key that is automatically attached to this group or action via a specific naming. So group or action prefix and then .text or .description for the relevant texts. And you can even navigate here from the message resource key to the actual action right from the resource panel as well. Other attributes also have completion. So for example, we can put it relatively to some other action inside the group, and this will pop up the auto-completion for all the available action IDs. So you will be able to quickly enter the proper action ID right here. It also shows the icons of the actions and the underlying text. So this is hopefully a very convenient way to look up related actions in the configuration here. The other thing I forgot quickly is the extensions also allow you to navigate to the actual extension point definition. So here we can see the underlying extension point and can then see any related interface or extension point bean class. And while we are here, we can also see that we have some small icon here for the extension point name. So this also has code inside. We are going to look at the code level code inside a bit later. But we can see that this allows us also to navigate to the corresponding declaration in the plugin XML. So we can jump from the source to the extension point declaration and vice versa. Right, so this is a bit about the completion and code insight. This is very interesting, very powerful for extensions mostly. I think the coverage of all the attributes and code insight is pretty much complete right now for all the known extensions from the IntelliJ platform. And if you have custom extension points, you can also look up the corresponding supported attributes right here. So these are all the supported things in the extension point code inside. For example, required elements can also be annotated in the extension point declaration, so the plugin XML will automatically insert such attributes. Right. Next part, inspections for the plugin XML. So when we open the list of inspections that we have right here for the plugin descriptor, there's a couple of dedicated inspections here. And I want not to talk through all of them because that would be too much, but highlight a few which are quite interesting. So the plugin XML validity is basically the basic inspection that checks the semantic validity of all the plugin XML main elements, as well as required extension point properties, for example. There is dedicated inspections to support internationalization. So if you didn't specify message keys but hard-coded texts, this inspection will highlight them and also offer you quick fixes to extract such text into message resources, which is highly recommended because we think that providing internationalized plugin text is very important in the long run for your plugin. Somewhat related is a check for proper text capitalization to make sure that, for example, any strings that are shown in the UI, like, for example, the inspection name, are properly capitalized and so on. There's another special one, plugin logo check. So if your plugin doesn't have a proper plugin icon, that will be shown in the plugin Explorer, then this will also be highlighted, so you don't forget about providing one. Right, so these are several inspections that we have here that work on the plugin XML. Check them out. And I want to stress really that it is very important to take any kind of warnings and errors from these inspections very seriously, because in the end it can mean that your plugin may actually not work maybe in a newer version of the IDE, or might have some performance issues or memory issues if you do not follow the recommendations that we give right here. So let's switch to the code part of writing a plugin, and we can see that the number of inspections that we have for the code is about 10 times as high. Many of them are very specialized, so they pertain to some very specific API, for example, or even like a very specific method even, or extension point that can be checked for specific setup issues. Again, these are very important to take into account and make sure that your plugin fully conforms to any recommendations that you got from here. Many of those are really improvements, but some of them are really quite critical for the proper behavior of your plugin, especially if you want your plugin to be fully dynamic so that it can be installed and uninstalled without restarting the IDE. There's a couple of related inspections for that, for example. And it's really worth going through all a list of these things. As you can see, some of them are not enabled by default for various reasons, but you should definitely take a look at them. Let me highlight one inspection that is also newish, and this inspection is called can be dump aware. So what does dump aware mean? That is a mechanism that allows a specific API to work during the indexing mode. So while indexing is on, and certain functionality can fully work without accessing the indexes. And as such functionalities should be marked dump aware by the plugin implementation, so that the actions and highlighting, for example, will be available to the user during dump mode, during indexing. And this is a bit newer inspection, and the way it works is that all API that can be dump aware is marked with another marker interface, which is called possibly dump aware. And as soon as you actually implement the dump aware interface in your extension point implementation, for example, then the IDE will consider this one as dump compatible. And to find such opportunities, you can use this inspection. It is not enabled by default because in the end, it requires a thorough manual check of your implementation, whether or not your implementation might need indexes or not. That is something that the IDE cannot determine by itself. So this is some kind of manual check by the plugin author. And once you have enabled this and run it over your plugin sources once, then you can add all the places that you went through, which are definitely not dump mode compatible. You can add them to this ignore classes list, so that the inspection will no longer recommend checking this specific place. So yeah, that's something that probably many plugins haven't done yet systematically, and it can really improve the usability of your plugin a lot if you do this. So for code, what do we have here? As we showed previously, we have some code insight here as well. So for example, we have here completion for the extension point again. The same is true for some other API, for example, the registry, which is a kind of low-level key value store to expose and manage somewhat hidden settings. And these registry keys are also completed and have full code inside here. Your plugin can also expose its own custom registry keys via extension point. This is just one of the many completion things where we have code inside here in the IDE for plugin code. Another one which was added in 2025.1 as well. There is a lot of code inside for anything related to actions. So in some cases, you might need to access an action from code via its ID. And as you can see, we have also code inside here right now. So again, we have the same auto-completion now in the code as we had in the plugin XML for the action configuration. And you can quickly go to the action declaration, or even also find usages of the action or group ID in your code or in other places. There are some special inspections in code for description files. So description files are, for example, the text that you can see in the inspection settings dialog. So every inspection has its own description. And you can use the scatter icon here to quickly navigate to the registered description file from the inspection. For basically everything that is registered in the plugin XML, there is another gutter icon to navigate to the declaration in the plugin XML. We have a similar thing for intentions, which also have before and after files to show the different states, and the same also for postfix templates. Right. And of course, if some description file is missing or wrongly configured, then this will be highlighted with the inspection. So let me quickly break this. And it doesn't work. Okay. Well, I guess that is a bit strange. Well, it usually works. What else do we have for code? There is an interesting way also to access actions if you have, for example, your own custom test cases. And this is also something new in the 2025.1 release. You can use language injection. Let me find an example where not everything is red. So for example, here we have injected DevKit action ID reference into this constant, and this will also give us code insight to an action ID. So whenever you have such constants in your code, you can annotate them now using this language annotation from the IntelliJ plugin and enjoy code insight from here. Right, so that's a very rough browsing around the code insight features and inspections that we have. Again, please check them out, read the descriptions carefully, and try to make your plugin green, basically. All right, the next part, the next tool that we want to cover today a bit is the PsiViewer. So PSI is Program Structure Interface. That is basically the underlying semantic tree and structure that we have for all the supported languages in the IDE. So every language has its own dedicated PSI implementation that models the underlying language accordingly. And when writing a plugin, either for your own custom language or extending some language, for example, by providing additional inspections, you will usually need to understand and navigate this PSI tree to know where to hook in, basically, for example, for highlighting specific parts of some code or for adding auto-completion or references. And the IDE has two ways, basically. The first one is a standalone plugin that you can install, which is called PsiViewer. And this has a tool window that allows you to see the current editor, the structure, and then you can also inspect the underlying elements here and see all their properties. The big advantage is here that you can do this with any open editor and just quickly jump to some part, and it will automatically also sync to the corresponding element in the tree. So that's very convenient to browse some PSI tree online, basically. The other thing is the other PsiViewer that we have is built into the IDE and is available here from the tool menu. It is basically the same, but the big difference here that this is shown in a modal dialog. So this is a bit, more blocking, so to speak, and probably more useful in other contexts or easier to navigate in other contexts. Again, we see the whole tree here, and we can inspect all the properties and even navigate here to related elements in the tree. What else can we see here? We can switch between different tabs here. For example, there's a references tab, which allows us to inspect any kind of references which are attached to this PSI element. And we can see here, this is just what I showed before. So this is actually a reference to an action ID, which is provided by the Plugin DevKit. And we can see the underlying reference implementation that is attached to this string literal right here. So whenever you need to understand where references come from and what the class name is, this is a very easy way to inspect this. The next tab is called block structure, and that's basically the formatting model of the source. So whenever you need to write some kind of formatter or understand some formatter, this is the easiest way to see how the formatting model is done behind the scenes. And the last tab is the stub structure. So stubs are basically some serialized parts of the PSI tree, which are used to model externally visible declarations in most cases. This is used to speed up resolving mostly. So you don't have to build the whole tree every time, but you can just look at the stub indexes, for example, and quickly locate something via its name. And this stub structure here allows you to quickly inspect all these stub elements which are available in this specific file and structure. All right, so much about the PsiViewer or PSI viewers. And I would now like to hand over to Jakub, who will show you a bit about the UI inspector. Jakub.
Yes, thank you very much. Now we're going to talk about the UI inspector, which is, again, an internal tool within JetBrains IDEs and Android Studio as well. And as it is internal, Yann already mentioned in the beginning that we have to enable the internal mode via properties. I'll just showcase where this actually is, in case you didn't check documentation. So basically, in the help, edit custom properties, we're supposed to set this property. Idea is internal equals true. Then simply restart your IDE and you get all the superpowers that come with the internal mode that we use for IDE and plugin development. Since now, you can access the UI inspector in 3 ways. The first one is the top menu tools. Oh my, so many options. Internal actions, UI, and UI inspector. So that's the first option. Pretty long. You can use the magic Shift combination. Go to actions and type UI inspector. Or, as you already see here, you can use the shortcut. So by pressing Control and Option or Control Alt on Windows and Linux, Control Option and left click on an UI element. That will also open UI inspector, highlighting the specific UI element of your interest. All right, what can we do with that? For those who come from web development industry like me, we can compare that with developer console tool present in all modern browsers. So whenever you work with CSS, JavaScript, you have access to this console, and it behaves in a similar way. So on the left side, you can see the UI tree, and we can actually select specific elements, and they are supposed to be reflected on the right side, well, with the color. So on the right side, we can see Juni icon highlighted, but we can pick something else. And in the main part of the window, we can see some information about paddings, borders, and all the metadata that comes with this UI element. So for this one, we can see that this is a part of tool window stripe. And we can get the information about action ID, action class, tool window ID, and everything else, all swing properties or custom properties we use while developing the IDE. Some of them are possible to be adjusted. I don't know, like location, we can put here number 10, so 10 more units from the left. And you can see that it moved for a bit of seconds. But due to UI refreshing, it actually gets back to the actual position. All right, what can we do with all those information? Well, in what context can we use those? The first option is actually figuring out where we are in the UI. So this button is not something kind of detached from UI, but a part of tool window right toolbar. So that means we have also something like left toolbar and bottom toolbar somewhere there. Yeah. So we can figure out what is where, and we can start playing with those information in various ways, such as we can, for example, start with Gradle tool window icon and get the tool window ID, which is simply Gradle. Now let's, I will switch to Kotlin notebooks, which has the power of running Kotlin code. And recently we've been experimenting with running the IntelliJ platform code yet in the IDE process, which works pretty nice. So I'll use it for presentation today. And the very first element that we have here is we'll refer to tool window manager, get its instance, access tool window via Gradle ID we just used, and programmatically via our plugin, or here in notebooks, we can execute anything on the object we've just retrieved. So as you can see, it just opened on the right side as we would click on it manually. What else? We can also spy on more complex, more sophisticated elements of the UI. So not only things that you already see in front of you, but we can navigate, for example, to, I don't know, there are some icons here. Execute Gradle task. So whenever we Command Option click on this icon, we can see the action ID here. So let's copy it. Get back to the notebooks. And yeah, I've already put the action ID here. So here we are accessing the action manager, requesting for this specific Gradle execute task action, and we'll simply invoke it with a few lines of code. And yeah, this is exactly what I've expected to see. So we can again programmatically refer to some UI elements, to play with them, or even I don't know, adjust their UI, like when you create a theme for IDE, JetBrains IDEs, you can check exactly properties of specific UI elements to adjust their colors, paddings, fonts, etc. So this is a pretty useful tool to get to know with the UI presentation of our tools. All right, but other use cases. So we can currently play with styles, with properties of UI elements, refer to specific elements like tool window, action, etc. Via code. But we can also use this UI inspector for integration test purposes. So recently, Maxim Kolmakov published a couple of blog posts in that matter. And I'll just quickly, well, it basically boils down to a small addition to your Gradle build script. Not much, mostly copy pasting. Whenever you use IntelliJ Platform Gradle plugin in the latest version. And having this implementation, this configuration in place, we'll just run the integration test Gradle task. Again, we can use this execute Gradle task option, which is really powerful and speeds up the process. And we will check how this can be used in actual integration test. So by default, we run this integration test. As you can see, I already had it in the recent configurations. And it opens a new guest IDE, like when you run IDE for manual testing purposes. All right, let's close that. So yeah, here I have some commented code from our documentation, which is oh no, not this one, which is a great demo anyway. So accessing the IDE frame, so the whole frame, we can use already predefined helpers that this UI testing framework brings for us. The first one is search everywhere. But yeah, you have to, again, put some action ID here. Another great method to figure out what action ID we have to use is simply using, again, Shift, switching to actions. And here we can look for this action, search everywhere, Command Option, click on it, and yet we have search everywhere action ID. So we know exactly how and what can be called by integration tests. So let's try it out. My IDE is still running because it's put on hold for 30 minutes just for demo. I believe when running actual tests, you will not use that. And yeah, it has different currently zoom, this guest IDE, but having search everywhere open, I can adjust that to the proper resolution. Yeah. Okay, let's close it again. This framework provides, again, some shortcuts. So having the search everywhere action involved, so the search everywhere dialog on the top, we can use another code to access programmatically the UI elements. So we'll just type readme and execute the preview button. Let's try. I'm not sure if you noticed that, but I didn't move my mouse, but this framework did that for me. So yeah, we have this README. And there is a URL present here. So now whenever you run UI integration tests, you can access local server, which presents to you in pretty different way, but still content. How to? Oh, yeah, I want you here. Content currently visible on the screen, which you can access via XPath when creating more tests. So this is pretty similar to UI Inspector, but gives you a slightly different information. Stick this one to the left side. So here, well, on the right side, let's simply search for search everywhere dialog, and there is unfortunately none. But getting back to the IDE, we'll open it, and on the right side, and just refresh the page, it appears in the tree. So we can check all elements that are currently on the left side present. Again, pretty useful to when you create complicated tasks like some specific scenarios of typing things, clicking, and resizing, whatever. All right. What else could be done here? Let's close all the stuff right now. And I can comment this out. So focus again on the Gradle tool window. So via using the UI inspector, we can simply figure out that I need some small help here. Open grade, okay. So yeah, UI inspector and integration tests is not operating on actual IDs, but on UI related properties. So here we should rather search for some accessible name, which is again Gradle. So we could use whenever we would like to open Gradle tool window while testing the UI, we should refer to the accessible name here. Then, similar to that, I just close it. Let's focus on the execute Gradle task action. And here, the name is pretty different than ID. So this is kind of human readable name. And then having this window opened, we could also check the class for this element, like search field, to type something within this this input element. So now let me just copy paste some code from the other window. And here I am missing still the UI, which was, hold on, I lost that. XPath, right. Okay, I have some technical troubles here. Yep. So that was missing. UI robot, wrong context. I don't want to be in ID frame. Copy, paste. Yeah, that's exactly it. The type text. Okay, something is lacking here, UI keyboard, but we'll get far enough. Or we will not get far enough. Yep, that was because I don't have Gradle here. Huh. Okay, so that's the reason I didn't have a Gradle tool window there. Anyway, I will spare you debugging process right now. However, in our documentation, you can notice that everything I mentioned before, so accessing UI element by accessible name or class, are actually supposed to work, and everything is documented, so you can refer to our IntelliJ platform SDK documentation and search for both UI inspector to get more information, or testing and UI testing categories for more articles in that matter. All right. I think that will be enough about UI Inspector tool and its superpowers again. So let's switch back to Yann. Thanks.
Thank you, Jakub. So this leaves me with the last small topic, very special topic, Index Viewer plugin. So what are indexes? Indexes are basically hash maps that allow you to store and retrieve information based on keys very quickly. And this data can be built and collected by the plugin. So for example, the Plugin DevKit plugin itself maintains also several custom indexes, for example, to store all the available extension point declarations that it can find. So this allows us to quickly, for example, provide the auto-completion feature for all the extension point names. These indexes can be implemented by a plugin, and sometimes it's a bit difficult to understand and debug these indexes. So for that, there is this special plugin, Indexes Viewer, and it comes with a tool window here on the right, and we can see all the file-based indexes here on the top. And further down, we have all the stub indexes. And we can see very quickly the current version of the index, the number of keys, and the size on disk for every index. And now we can simply double-click on some index here, and we can then simply browse its contents. Excuse me. So this is very useful when you build your own custom index. and you need to debug whether or not the contents are correct or complete. So we can see all the index keys here and the associated data. In this case, it's not very speaking data. So, for example, XML tag names shows all the XML tag names which are registered somewhere. And we can see the associated data here. You can also go from the index to the implementation. So this now opened the actual underlying index implementation. And whenever you have such an index implementation open, you will also have the gutter icon here to quickly go back to the data and browse it. There is one more interesting feature about IndexViewer, and that is allowing you to right-click on any file and use the show index for file context action. And this gives you a summary of all the indexes that contain data associated with this file. So we have some stubs, we have an entry in the file types index, an entry in the DOM file index, and then the two Plugin DevKit specific indexes, which also have data about this specific file. So that's kind of a reverse search. What indexes do have data for this specific file. Right, so that's the last small feature we wanted to show today, the index view. As we are coming to the end of this webinar, just let me highlight quickly that there is a really, really huge long list of internal actions once you enable the internal mode in your IDE. A lot of these are probably not so much interesting for plugin developers, but more for people working on the platform itself. But nevertheless, I would encourage you to browse it and play around with some of these things. For example, you can also manually enter the dump mode to test your plugin, whether it works correctly during indexing or not, and so on and so forth. All right, so we have some minutes left for some questions. And Jakub, what do we have as questions for today?
All right. Let's start with the, well, I've started already a couple of them. So the first one, yeah, this is for me. Is the Kotlin notebook available now? Well, yes, it is available in Marketplace. Even this IntelliJ platform integration, let's say, this is possible. However, it's not that straightforward. I'm currently in process of discussing that approach with the Kotlin notebook team, who approached me with this idea, and I really like it. However, the long way long way approach I could share in our platform JetBrains.com forum, so you can play with that. Check if you like it. Yeah. So again, platform JetBrains.com. Remember that. Next one. Okay, that was again related to UI Inspector. I believe it opens opportunities to have JetBrains MCP. As far as I know, there is already something like that created, MCP plugin. However, I don't know if it is public, but yeah, having that kind of tested, published, we can make our JetBrains IDEs available for external tools as well. And currently, AI Assistant already can refer to UI elements currently visible on the screen. So yeah, this is completely possible. Next one. I saw that IntelliJ community switched over to Bazel for its build. Will the plugin template follow suit, or will it remain Gradle-based? Yann, want to comment on that?
As far as I know, well, first of all, we have not switched yet in that sense. We are building this Bazel-based infrastructure, yes, and the plan is to use Bazel in the future, but as far as I understand, this will not be happening for third-party plugins, because to be honest, I think the advantages that you gain from Bazel mostly play out in big projects, and the IntelliJ project is really big monorepo, and that is the main motivation for trying to switch to Bazel instead of our own JPS build. So that's mainly for performance reasons. And as far as I'm concerned, we currently do not have plans to provide any kind of template or recommend using Bazel for third-party plugin development. I guess in theory you could use it, but given that the Gradle plugin that we maintain really offers a lot of convenience functions and tasks, you would basically need to rebuild all of that in the Bazel world. And I don't see that happening right now.
On the other hand, I understand that still big projects already using Bazel could be interested in
yes,
such
of
solution.
course, yeah. Yeah, I mean, if your plugin is part of a big repository, and then you probably maybe even already use Bazel for building your plugin. But I guess for most standalone plugins, and this is really the large majority of things that we see on Marketplace, there is really no imminent pressure to move to Bazel in any way.
That's right. From what I know, the Bazel-related teams and the other one, which is Ampere, are already working on such solutions, but no promise. There are no promises when or even if such plugins for those build systems will be released. Okay, next one. Something for you, Yann. Is the pop-out modal view for PsiViewer only in the EAP?
I assume this is about this PsiViewer, which I showed. This has been available since forever. But for it to be available, you need to enable the internal mode, as we showed in the very beginning of this webinar. And then the built-in PsiViewer is available in all of the IDEs. So this is also not specific to the Plugin DevKit, which only works in IntelliJ IDEA. Yeah, okay, it seems Chris catched up on what I just said.
Awesome. Okay, next one is this. It could be great to add reindex button to the indexes. Really useful thing.
It might be possible to reindex only a specific index programmatically. And if you really want, you will probably find a way using the IntelliJ API, at least some internal API. What is there? I think it's also there for regular users. Definitely, if you are in internal mode, there is a file invalidate caches action. and that will basically remove all the indexes completely and rebuild them from scratch. And this can be useful if you have some kind of inconsistencies in your indexes, maybe also caused by some plugin that you installed or that you removed, and this will basically force rebuilding the indexes.
Right. It looks like we don't have any questions anymore, but
Okay.
let's give maybe a few seconds more. Maybe someone will decide to jump in. Yeah. All right.
So we have one closing slide. Right. So if you need any more information about plugin development, you hopefully know where to go. If not, here are some very interesting ideas. You can contact us also on LinkedIn or on Blue Sky for Jakub. Yeah, we hope that this presentation was interesting for you, that you learned a bit more about all the tooling that is provided for plugin developers. Of course, in 1 hour, we can only cover as much as fits into such a small amount of time. So there's plenty more to explore. As I encouraged you previously, please check out the internal tools action, check out the UI inspector. We have a very nice page called Explore the IntelliJ Platform API, which is somewhat related if you are looking for specific functionality or need to understand how things work in the IDE behind the scenes. So I hope that we give you a lot of ideas and tools to build your plugins. And with that, we say goodbye for today and look forward to read from you on the platform forum and get your input. If you have any ideas for tooling that you would like to see or any enhancements you would like to see, please join us, join the discussion here on the JetBrains platform discourse. We are happy to help you.
Thank you very much.
Bye-bye.